Okay, the grace period already over because for every class I'm giving 5 minutes of time to join to switch over from the previous class to this one. So now the time is 2:25. So my voice is clear, students?
Yes, ma'am.
Okay. So yesterday we seen that discrete Fourier transform for linear filtering of long duration sequence means if x of n is a long duration sequence, the computation of circular convolution is not possible. So that's why we are dividing the x of n sequence into we are segmenting the x of n sequence into subset of sequences. See here, on the right hand side, you can see that our x of n is having L number of samples always, right? It is having L number of samples. So this long duration sequence x of n is divided into small sequences called, small segments called the subsets of x of n. So we are dividing x of n into x1 of n, x2 of n, x3 of n, and so on. So here, to divide this sequence, to divide this one, so to find the long duration sequence, we are following the two methods called overlap save method and overlap add method. So first let us see that what is meant by overlap save method, what happened in the overlap save method. Now we will discuss. Okay, so now I'm going to explain about the overlap save method. So in this one, the major drawback with the long duration sequence is that the circular convolution takes a lot of time to compute. That's why we're dividing the long duration sequence into the small segments called the subsets of x of n. So see on the right hand side, x of n is divided into x1 of n, x2 of n, x3 of n, and so on. Then we are computing the convolution between the sequences. So for that, we have to follow some steps to compute the overlap save method. So always we know that when you are performing a convolution means we need two sequences called x of n and h of n. Here h of n is having the length m and x of n is segmented into, it's a long duration sequence segmented into blocks of L samples. So in the procedure, first step is that we have to compute the n value. So we have to select the value of n, which is given by 2 power m, where m is called the length of h of n. So that is the first step. Okay, in the overlap save method, find the n value, select the value of n, which is nothing but 2 power n, where m is nothing but length of h of n. And coming to the step 2, in the step 2, the length of h of n is made n by padding L minus 1 zeros. So this is the same step I repeated in the last class, right? So for the length of h of n is made n by padding L minus 1 0, so that our sequence would be h of n sequence would be h of 0, h of 1, and so on, h of m minus 1, and at the end we are padded with L minus 1 zeros. That is the step 2. So first step is compute n using 2 power m formula, and next is pad L minus 1 0 to our h of n sequence. Third step is we have to divide the sequence x of n into subsequence of length. Okay, so see here on right hand side I am segmenting my x of n into smaller blocks called segments. So where each segment is written like this. So x1 of n I'm writing as it is always start with m minus 1 zeros. Okay, so what you have to observe here is that h of n is padded with a 0 L minus 1 zeros at the end of the sequence. But when the long duration sequence x of n is considered, which is divided into subsequences called x1 of n, x2 of n, x3 of n, where each subsequence, before the sequence, we have to pad with m minus zeros. M minus 1 zeros are padded in the x1 of n sequence. Later we are writing the samples of x of n, x of 0, x of 1, x of L minus 1 here. M minus 1 zeros are padded with x1 of n sequence. Okay, after writing x1 of n, come to the x2 of n. Another segment of x of n is called x2 of n, which is written as x of L minus m plus 1, and so on up to we are repeating this up to x of 2L minus 1. So before starting x2 of n, it must be padded with m minus 1 samples of x1 of n. So this is the concept I'm explaining. Okay, manam problem cheste meeku clear ga untadi, but before that you should understand the concept. So next is x3 of n is, again x3 of n started with the samples x of 2l minus m plus 1 and so on, x of 2l minus 1, etc. This is repeated up to x of 3l minus 1. Means we have to add m minus 1 samples of x2 of n in the x3 of n sequence. Okay, this is a step 3. And step 4 is, after finding x1 of n, x2 of n, x3 of n, and so on, we can compute the y of k. Y of k is nothing but h of k into x of k. Already we know that convolution formula. What is the convolution formula? So everyone, we know that y of n, circular convolution of, or the linear convolution of, suppose when we are taking the discrete Fourier transform. So already we know that when the discrete Fourier transform of, when the circular convolution between x of n and h of n is applied, okay, so then we are calling it as y of n, right? So which is nothing but the discrete Fourier transform of circular convolution of the two time domain sequences is equal to multiplication of their frequency domains. So right, this is the convolution, right? There y of n is nothing but y of k is nothing but the multiplication of the frequency domain signals, right? So this is the formula we are using generally. So likewise, you have to compute for each sequence, for each subsequent, subsequence x1 of n, you need to find out the new sequence y1 of n. For x2 of n, you need to find out y2 of n. Similarly, for x3 of n, you need to find out the new subsequence y3 of n. Okay, so for each segment, for each subsequence, you need to find the new sequences called y1 of n, y2 of n, y3 of n. These y1 of n, y2 of n, y3 of n are obtained by from the y1 of k. Okay, so where y1 of k is nothing but the multiplication of x1 of k into h of k. So after that, so here instead of multiplication, you can use the circular convolution between x1 of n and h1 of n, so that you will get y1 of n. So here y1 of k, by applying inverse discrete Fourier transform on y1 of k, you will get y1 of n. Okay, so the same procedure we are repeating to obtain y2 of n, y3 of n. Okay, so after getting this y1 of n and y2 of n and y3 of n values, what you have to do is, see this diagram, you can understand easily. So you have to remove m minus 1 samples from the y1 of n, and similarly m minus 1 samples from y2 of n, and remove m minus 1 samples from y3 of n, then add y1 of n, y2 of n, y3 of n, then you will get the new sequence y of n. So this is the procedure we are following. This is the procedure we are following. What the procedure last step is, first m minus 1 samples of y1 of n, y2 of n, y3 of n are discarded, and remaining samples are fitted one after the other to get the final sequence y of n. Okay, got it? This is the procedure. So the first step is to solve the overlap save method problem. The first step is you have to select the value of n, which is nothing but 2 power m. After that, step 2 is pad your h of n sequence with l minus 1, 0. Next, step 3 is divide your long duration sequence x of n into subsequences called x1 of n, x2 of n, x3 of n, where x1 of n, the samples of x1 of n is, first of all, m minus 1 zeros are padded in the x1 of n sequence, followed by the samples of x of n. x2 of n, in the x2 of n, the first samples are padded with m minus 1 samples of x1 of n, then followed by the samples of x of n. x3 of n is similarly m minus 1 samples of x2 of n is padded, then followed by the samples of x of n. After finding x1 of 2 and x2 of n, x3 of n, we need to calculate y1 of k. So from y1 of k, we need to find, by taking inverse discrete Fourier transform, we can find y of n. Or else simply another shortcut formula is taking the, means this 2 indicates what? We are computing the y of k and y of n using DFT and IDFT. So another method is also there to compute y of n, which is nothing but by taking, this is second method. Taking circular convolution between x1 of n and h of n will give the y of n. This is another method to compute y of n. And this is another method to compute y of n. That is how we can compute y of n. By applying DFT, we can find y1 of k. After taking inverse discrete Fourier transform, we can find y of n. So two methods we can follow. Any method you can follow to find y1 of k. Similarly, you can find y2 of n, y3 of n, and after that finding y1 of n, y2 of n. What you have to do? You have to discard m-1 samples in each new sequence. Okay, after discarding the m-1 samples, just you fit all the samples one after another to get the new sequence called y of n. So this is the procedure we are following to find the overlap. Same method. Same method. So now let's see the one problem related to this. So first take this problem, find y of n. So we are exercising problem